presenting on my capstone topic, which is invasive species encroach shaped by changes in land use within the UTSC property. So starting off with some brief background on invasive plant species, they've been long known for their detrimental consequences and impacts on landscapes. They've been a management concern in Ontario over the last few decades. Invasives are typically found alongside forest edges where disturbance is high and eventually spread further into woodlots as conditions become more favorable for them. They're also tied with well-known negative consequences, such as competition with native plant species, as well as soil degradation. And here are just some of the most common examples of invasive plant species found in Toronto. They're also the species of focus for my project. So going in order, you have Norway Maple, dog strangling vine, Tartarian honeysuckle, common buckthorn, and garlic mustard. All of these species have become targets for management interventions to control the increasing present distributions we see across woodlots. But what about the past conditions? Often overlooked in management plans are the past land use changes, which have influenced the invasive species distributions we see today. Consider urbanization, for example. It's often tied with drastic shifts in land use, such as the development of roads, buildings, and infrastructure in general. It's a good example of short-term development periods followed by long-term repercussions. Another example being agricultural land conversion, which is another good example of past land use, where much of Toronto away from the downtown core was historically converted to include croplands in the late 1800s. So for this project, we consider the University of Toronto Scarborough campus, which is a property shown here on the right. Just some brief background on the property. It was acquired in 1963 in order to expand campuses outward from the downtown core. And shortly after, in 1964, campus development began. Regarding the forested property, you can see that there are many woodlots kind of isolated around the property going all the way back here. But the woodlot that encompasses most of the woody cover on the property is actually the Highland Ravine woodlot, which is this one right here behind the campus property. It also doubles and has become an important recreational green space in Scarborough for residents and students, as well as being a remnant of the Highland Ravine forest that houses significant biodiversity within an urban context. So a bit more background on the campus property. We have two aerial images here, one taken in 1954 and the other one taken in 2011. And yeah, historically, this land was actually purchased by Miller Lash, who was a UofT alumni in 1911. And you can see that he decided to clear much of the property to include agricultural croplands and a working farm right here where the main campus is now situated, as well as down here to the south where his estate was and still is. But looking at these images at a glance, you'll kind of notice the big glaring change, which is the Highland Ravine woodlot itself. So you'll see that it used to be an interconnected forest landscape and later on was split in half by road development. So moving on from the background, the objectives for this project were one, to see if there were any differences in invasive species distribution and presence between the forest interior and edge, and two, to see if there are any connections between invasive species presence and land use changes at the property over the last 70 years. Regarding methodology, we sampled 43 randomly distributed plots. You can see them on the map here, each at 400 meters squared. And regarding our survey protocol, we surveyed for ground vegetation and tree species presence at each plot, as well as percent cover by species per plot. And we also took measures of DBH on anything above 5 centimeters at breast height. So jumping into the results with regard to changes of woodlot area over time, you can see it on the funnel chart on your right. So overall woodlot cover only saw a 6% decrease shown in blue, which is pretty small, all things considered. It could be explained by the increase in number of satellite woodlots over time, which kind of compensates for the larger woodlot losses, such as the Highland Ravine woodlot in green, where we see about a 10.5% decrease compared to 1954. And the southern woodlots remained virtually the same over time since being historically cleared in the early 1900s. Here's just a table looking at the 5 most common invasive species. The table summarizes plot presence across all plots sampled, average percent cover in plots where these species were found, and an estimated area coverage in meters squared. So Looking at this, you'll notice that DSV was easily the most present species across 95% of all plots. It also covers the largest area, 3,950 meters squared. It's followed by Tartarian honeysuckle, and you can see the other species here. And while the summary statistics present the big picture, to better understand how past land use changes could be linked to these distributions, it's better to consider specific woodlots. So to better explain this, I split the woodlot into 3 compartments. So you got the satellite woodlots here highlighted in blue. You got the Highland Ravine woodlot here in green, as well as the southern woodlot here in red. And we'll take a look at each one separately. So starting off with the satellite woodlots, we have a histogram on the left here, which just shows average percent cover per plot. You'll notice that buckthorn is easily the most abundant species. And on your right, you have a map just detailing buckthorn relative cover by plot. And of the 4 plots sampled here, you'll notice that 3 of the plots have buckthorn within the highest percentile in our legend below. And the remaining plot has it at the second highest point, which just kind of instills the abundance here. And this is an interesting finding given the past conditions. The central woodlot highlighted in blue here and the northern woodlot highlighted in red were actually left to persist over time with campus development. You'll notice here that the campus just kind of kept these in place and built around it, put in a residence here and some buildings shaped around. And the northern woodlot ends up being surrounded by parking property, but nonetheless retained. And then another interesting thing about the northern woodlot is it didn't, unlike the central woodlot, it wasn't natural and it was actually planted. You can kind of see it here in picture B, where it's intensely row planted. It's likely a pine plantation based on what we see today. And given the number of houses that kind of pop up around here, it may have been a resource stand. And yeah, regarding the dominant invasive, which is common buckthorn here, you'll see an increase in the number of hedgerows planted over time, which may help explain this. If you look at 1947, there aren't many as apparent, and as houses start popping up here, you'll notice more and more hedgerows. And common buckthorn being an oriental shrub, which was commonly planted in hedgerows and windbreaks in Europe, may have been planted here as well by European settlers, potentially. And if that being the case, could explain the buckthorn abundance we now see today, since the proximity of these woodlots are so close to these hedgerows, it could help explain buckthorn presence by seed dispersal. Also, both these woodlots being really small and exposed, the conditions really favor buckthorn success. Next up, we'll take a look at the Highland Ravine woodlot, which is the only woodlot compartment that was actually large enough to have a defined interior. And in this case, we defined interior by a 50-meter buffer from the edge, which you can see by the polygon here. And any other plot that was closer than 50 meters to the edge was considered edge plots here. A total of 12 interior plots, and we had 13 edge plots. The histogram on the left details average percent cover per plot, where you can see, surprisingly actually, that common buckthorn and Tartarian honeysuckle are more prevalent in the forest interior when compared to the edge. And DSV is also pretty apparent in the interior, but not as much as the edge, whereas garlic mustard and Norway maple are just more prevalent on the edge. And taking a look at this map again, interesting to note here, and something we'll talk about in the next slide, is the presence of buckthorn along the southern extent of the forest interior. You'll notice that these 3 plots actually have buckthorn within the highest percentile described in the legend below. And yeah, that's something we'll take a look at just now. Looking at the historical context, you have Morningside Road development highlighted in red here, where it was historically a connected landscape and essentially just split what was the forest interior and created an edge on the western side of the property. Regarding the buckthorn and Tartarian honeysuckle, which was more present in the forest interior, this may be explained by these invasives having fruit seed dispersal systems, where small mammals like squirrels and birds as well may have taken the fruit into the forest interior, where habitat quality tends to be a bit higher, and they could have just spread seeds that way. Additionally, something important to note is the presence of the largest buckthorn that we've seen by far. It was the largest by like 15 centimeters across our plots. And it was actually situated right around here at this plot specifically, which was right within the interior, but along the edge bordering road. And this could be an important seed source, which also helps kind of explain why we see an increase in buckthorn presence along this southern extent of the forest interior. Another interesting thing to point out here is the planting of edge buffers. which you can see in the blue box here. It's tough to tell, but there's like 5 to 6 rows of trees planted here, and you can kind of see it fill out over time, eventually almost even becoming indistinguishable from what was the forest. So it was historically cleared, and it was likely planted by the previous owner. It was actually purchased by another company after Lash passed away, and then it may have been motivated by the company just wanting to make the land look a little bit more appealing to a future buyer. Nonetheless, it's an interesting change in land use relevant to plantings that kind of creates and increases the capacity of this woodlot to buffer against edge effects. It's important to note that it's pretty small though, because like this is a really small space and it may not have any meaningful effect on buffering against the edge, but it's still cool to see how past land use changes can have positive effects as well.
10-minute mark.
Yep, thank you. Next, we'll take a look at the southern woodlot. On the histogram on your left here, you have Norway Maple, average percent cover per plot, and you'll see it's easily the most abundant by far. And another interesting note here is that buckthorn is virtually absent, which we haven't really seen across the other two compartments. And on your right, you have a map that details relative cover of Norway Maple by plot. Of the 12 plots sampled here, Norway Maple was found in every single plot, and it was within the 2 highest percentiles in our legend below at all plots. Yeah, so the story here are Norway Maple street plantings, which you can see in red, which is the rec field where there were Norway Maple street plantings in the 70s and 80s. It eventually becomes a parking lot, but the trees are still there to this day. And there are some Norway Maple plantings in the cemetery highlighted in blue here. And by proxy, there's the suburban development, which given the time likely had Norway Maple planting as well. And yeah, Norway Maple likely just bled into this woodlot given how close it's situated to all of these street plantings. And it also helps explain why Norway Maple isn't nearly as apparent in the other two compartments. The site is also now dominated by Norway Maple between 20 and 40 centimeters in DBH, which suggests that they've established this site a few decades back. And regarding the lack of buckthorn presence, it may directly be related to Norway Maple presence. Some findings suggest that the high shade density of a broadleaf Norway Maple canopy is very limiting to light availability on the ground layer, where another study controlling for light availability shows that it's one of, if not the most limiting factor to buckthorn abundance. So yeah, all in all, it's interesting to consider how these changes in land use relevant to development and even including plantings could influence the invasive species compositions we see today. In summary, I found that invasive species abundance with respect to honeysuckle and buckthorn was higher in the interior woodlot, likely due to the disturbances followed by road development, but edge plots still overall having slightly more invasive species abundance. Invasive species presence and abundance across compartments also seem to be linked to past land use changes surrounding the property. Examples include the road development like what we see in the Highland Ravine area, the agricultural conversion up north by the satellite woodlots, and plantings, which are interesting because they could also have legacy effects on the woodlot, like what we see with the pine planting, edge buffer, and Norway Maple in the southern woodlot. So for conclusions and recommendations, I think there needs to be consideration of historical context in management plans, because it could help understand the current distribution of invasive species we have now, as well as instill the importance of careful consideration of past land use changes, because they can have strong consequences on forest health and composition over time. With respect to the UTSC property, a complete inventory should be done to truly inform invasive species abundance throughout the woodlot. And being an educational institution, this is a prime example and a way to show and kind of further drive that point home of how historical context can have an influence on current composition and how changes in land use need to be considered over time. Just wanted to shout out these special people. Danijela for being an awesome supervisor. She really helped me out. Wouldn't have been possible without her. Colin for being my external supervisor. Adam for being an awesome partner. Catherine for teaching us VSP, and Maddie for helping us out with a few plots. And a shout out to the class as well. A bunch of awesome people, made some great friends here. It's been real. That's the end of my presentation.
Thanks very much, Krishna. It's great.
Thank you.
I'm going to pass the microphone over to Colin to begin the questions, and I see some other hands that are up, so we'll come around to those once Colin and Krishna finish their discussion.
Thanks, Krishna. Great presentation. My first question is kind of about the absence of buckthorn in the southern woodlot, and you suggested that you thought it might be a result of the dense shade created by the Norway maples there. And I was wondering whether the Highland Creek woodlot at the time of establishment would not have had an equally dense amount of shade. So kind of trying to understand why there would be such a high presence of buckthorn there. And you would assume there would be a fairly high density, even if it wasn't necessarily Norway maple. So any insight on that?
Yeah, that's a good point. My guess would be that in the Highland Ravine woodlot, you have a lot of like mature, very large, like super canopy trees, kind of like the red oaks that we have in there, some white pines and stuff like that. You still have maples, like sugar maples, but I would say just from being in those sites, doing surveys, that in those sites where you have these massive trees, you're still getting light in just because of the size difference between where the super canopy tree is and where the sub and the main canopy kind of starts. Whereas in the southern woodlot, where it was almost completely dominated by Norway maple, it was more like a tight connected. There wasn't too much difference in canopy. So like it was more connected and kind of, I think, had more shade density, I would say.
Okay. And the age would have been the age of the Norway maples versus the age of the, red oak or whatever sugar maple, the native species that would have been in the Highland Ravine would have been similar. I would imagine the Norways are going to be quite a bit younger than.
Yeah, they were definitely younger. Yeah.
Okay. And then my other question is kind of about seed dispersal mechanism. So in the Highland Ravine lot, which is large, you're seeing a higher representation of bird dispersed species versus wind dispersed species in the core. And I'm wondering if you felt that, how that would influence land management. So in terms of invasive species, whether that would influence like targeting bird dispersed species as opposed to wind dispersed species, or prioritizing those management actions.
Yeah, that's a good point as well, because like you said, we're not seeing as much like garlic mustard or even DSV inside the interior of the woodlot. That could be just based on a stronger edge buffer. So when it comes to managing those specifically, I think we should go with the fruit seed dispersed invasives, because we see a lot more Tartarian, honeysuckle, and buckthorn. I don't know how exactly we would try to manage for that, because it's kind of tough with like keeping birds out of the interior. But
well, I mean, you'd have to destroy the plants, I suppose.
Yeah, you would have to remove a lot.
But I was just curious because presumably you're going to want to protect the core.
Exactly. Yeah.
That's more intact as opposed to the edge. Okay, great. Thanks, Krishna.
Appreciate it.
Okay. Any other questions or comments?
I can ask one question if no one else.
Please go ahead, Danijela.
So Krish, I mean, it's not rocket science. We know that invasive species is a problem, but going on what we heard from Gary this morning, that this cannot be resolved by just one group, one government, one organization. It's a collective effort. So do you have some ideas how we could manage this at a property that it's a private property, UofT? Some ideas about stewardship?
Yeah, that's a great point too. And I think it being at UTSC makes it a special example, because you have a large student base and a lot of these people are pursuing degrees in related to biodiversity. They have a master's department related to ecology. I feel like you can do a student-led kind of buckthorn removal, Tartarian honeysuckle removal effort, tied with hopefully some city involvement as well, because the Morningside Park is just down the street. Maybe there's potential for a tied venture there. But yeah, having students involved, I think, could be the game changer here.
Thank you so much. Students a cheap way to manage invasive species. But joking on side, but I think it's something that none of this is going to be resolved waiting for things to be done by someone else. It has to be stewardship.
Yeah,
I think he should get as many Brazilians involved from the Amazon because they have great facility with machetes, and they'd make short work of all.
Strong
We
point.
can apply that.
But then is it really, do you really think like the limiting factor is manpower? I mean, is that just it?
No, I wouldn't say that, just because historically there's been like zero management at all at this property. So there just hasn't been anything done. So I wouldn't say it's manpower, but having strong manpower would definitely help.
I see. Thank you.
Really enjoyed it, Krishna. It's cool to see. Where'd you get your where do you get the photos, by the way? Is there like a good photo library? Like, how do you get those?
I actually got nearly all of those from the UofT map library online. So you can just download those as long as you're faculty or student. And then the City of Toronto Archives has a bunch too.
Yeah, the City of Toronto aerial footage goes back to 1939, actually. So, yeah.
Wow, and is that accessible to?
I don't think it's openly accessible. Daniela, we've went down this road a couple times. So I think that there's some loopholes to go through to get back.
There's ways you can get at it.
But I think so, yeah, maybe. Yeah.
Cool.
And I just would, I guess it's a question, Chris, but it's more like this is the heritage of doing nothing, right? Or you're looking at the change in landscape, and people have done nothing because they think green is good. And I think that's the issue, is that it's, I guess, a piece of education along with engagement. The university for sure, as just like Sanofi showed earlier this morning, should be involved in this in some corporate way. And part of it is the education that green is not always good, although, you know, we could make that argument, but somehow we've got to get in there, and that's part of your work, I think. It's not a question, but.
Yeah, no, that's a strong point too. It's tough to get people involved in stuff like this. I think like it being a school, you can get the students involved, but getting residents and stuff like that involved might be a little bit harder, but something we should do.
But even the students see it as green is good. Like if you go out there, oh, come out, you know, work in the ravines. It's great at UTSC because it's so wonderful. And, you know, when someone like myself or Daniela, or now you get out there and you see what's there, it's almost like a horror. And you just go, and it leads to your study is going, oh, how did we get here? And of course, you've provided some nice explanations of partly how we got here. Some of it is just ignoring, let me go back to an indigenous worldview, our responsibility to the land, like just sort of looking at it as to buy self and, you know, not thinking about its health, which connects to our health. But anyway, again, not a question, sorry.
Thanks. I think that's a great spot for us to end this session.